Good afternoon, everyone. Thanks for joining. I'm Matt Walker. I'm the Community Outreach Director with Clean Air Council. We're a member-supported organization committed to improving air quality in Pennsylvania and protecting public health. Welcome to the webinar, and thank you all for joining us on today's webinar called Natural Gas Pipeline Methane Leaks, Air Sampling and Technology Review Findings. Since 2008, Pennsylvanians have witnessed a large expansion in Marcellus Shale gas drilling, processing, and transportation. As the second largest producer of natural gas in the nation, Pennsylvania has been at the forefront of the natural gas rush. To transport the gas, many companies have focused on constructing or upgrading interstate pipelines. Constructing pipelines often requires extensive clear-cutting of trees, taking of private property through eminent domain, air pollution from construction of compressor stations, and impacts on wetlands and rivers. Demand for shale gas transmission pipelines is on the rise from plans to export liquefied natural gas and to construct natural gas-fired power plants across Pennsylvania and the region. The Energy Information Agency's latest analysis predicted that 2016 would be the first year that natural gas would surpass coal as a primary source of electric generation in the country. And the most recent EPA greenhouse gas inventory showed that industry has outpaced agriculture as the #1 source of methane pollution. While the number of drill rigs fracking in Pennsylvania has dropped substantially in the last year, mostly due to low gas prices, there continues to be a steady number of proposals for large-scale transmission pipeline projects designed to transport shale gas to various markets. Natural gas pipelines and related infrastructure pose significant risks to the communities in which they are sited due to methane leakage and resulting public health risks, as well as explosion risks and climate change impacts. Pipeline explosions can occur as a result of leaky infrastructure that produces a high enough concentration of methane. There have been several gas pipeline explosions in the United States in the last several years, including a recent incident in Salem Township in Westmoreland County, PA. Gas pipeline explosions have caused loss of human life, water pollution, air pollution, and property damage. Natural gas pipelines produce fugitive emissions of methane or methane leakages of other hydrocarbons throughout the network of infrastructure. A survey of the emissions from natural gas activities in Texas's Barnett Shale estimated that fugitive emissions from the transmission sector accounted for 35% of total fugitive emissions from natural gas activities. The number and amount of leaks occurring along various parts of the natural gas sector, including transmission pipelines, is still largely unknown. The transmission of natural gas also generates additional air pollution that can impact air quality and public health. Here in Pennsylvania, there are many concerns about the immediate health and safety impacts of air pollution leaks from these operations. Wherever methane is leaked from oil and gas facilities, it is accompanied by a host of toxic air pollutants that can pose a risk to the health of nearby residents. Besides being highly explosive, methane traps far more heat than carbon dioxide in the short term. On a 20-year timescale, the release of just 1 ton of methane has the same effect on climate change as emitting 86 tons of carbon dioxide. A warming climate increases the frequency of intense storms and abnormal weather events and leads to more days when it is unhealthy to breathe the outdoor air. The latest Pennsylvania Climate Impact Assessment concluded that Pennsylvania is on track for an alarming 3 degrees Celsius warming by mid-century. Methane pollution is responsible for 1/4 of the warming we're already experiencing. It is more critical than ever to understand the extent of methane leakage occurring and how to address the issue. If natural gas transmission pipelines or expansion projects are proposed, it is crucial that the public have access to the technical information they need to meaningfully participate in the decisions and ensure that public safety, health, and environmental protection are prioritized. Data and information about pipeline technology can often strengthen the quality of public participation in initial public meetings, public hearings, and commenting opportunities, and in the end, support a more critical review of a project. Over the last year and a half or so, Clean Air Council has contracted with experts to sample air quality near natural gas pipelines and also to assess the adequacy of Environmental Protection Agency recommended pipeline and compressor station technologies. And as I introduce you, speakers, if you could turn on your webcam, that would be helpful. On today's webinar, we have Dr. Peter DiCarlo, an air quality expert from Drexel University, who will discuss his team's findings from air sampling they completed near natural gas pipelines and related infrastructure in Pennsylvania. And we also are joined by Richard Kuperwitz, a pipeline safety expert with the engineering firm Accufax, Inc., and he will discuss his review of EPA-recommended technologies that are used for pipeline infrastructure. First, we'll hear from Dr. Peter DiCarlo. Dr. DiCarlo is an assistant professor with a joint appointment in the Department of Civil, Architectural, and Environmental Engineering and the Department of Chemistry at Drexel University. Dr. DiCarlo has a PhD in atmospheric science from the University of Colorado and a BS in biochemistry from the University of Notre Dame. He uses state-of-the-art instrumentation to measure the chemical composition of particulates and gases in the atmosphere to better understand air quality and climate impacts of human emissions. He has made air quality and climate-related measurements from planes, trucks, and stationary sites all over the world to better understand emissions, sources, and subsequent chemical reactions of pollutants in the atmosphere. Dr. DiCarlo also is interested in the intersection of science and policy and was an AAAS Science Policy Fellow at the US EPA prior to starting his faculty position at Drexel. Recently, Dr. DiCarlo has been identified as a highly cited researcher by Thomson Reuters in 2014 and 15. Dr. DiCarlo?
Thanks, Matt. Well, first I'd like to thank the Clean Air Council and particularly Matt Walker for inviting me to participate in this webinar. The work I'm going to present here is primarily performed by PhD students in my research group at Drexel University, in particular Doug Getz, who did the majority of the analysis that I'll present here, and help from Anita Johnson and Ben Worden as well, especially for the 2015 measurements. I'd also like to acknowledge funding for these projects, for which these projects would not be possible without our 2015 measurements were funded through a grant from the U.S. Department of Transportation, and our 2012 measurements, which I'll also discuss in briefly, were funded by the Electric Power Research Institute. Okay, here we go. So Matt gave a great background on why we care about this issue. In particular, the figure in the lower right side of the slide that I'm showing now shows in the gray bars the rate of new wells being added in the Marcellus Shale is decreasing, due in part to the low prices of natural gas on the market. But what's increasing in this red bar is the production. It's the amount of natural gas coming out of the Marcellus Shale and going to various markets. And so we have now made measurements in both 2012 and 2015 where the number of new wells has decreased by roughly half and the amount of natural gas produced has doubled during that time. So given that production and transport is increasing, we designed the study to investigate the emissions associated with these processes. In particular, new pipeline transportation technologies are currently being implemented, and we'll hear more about that in the second part of this webinar, to modernize and reduce emissions for methane and other species at pipeline infrastructure facilities. So Matt gave a great reason on why we're focused on methane. Methane, or also you'll see as CH4, it's the chemical structure, is the main component of natural gas. There are other associated gases with natural gas, but methane is by far the largest, greater than 95% of the composition of natural gas. As Matt mentioned, it's more powerful than CO2 as a climate forcer, and just a few % leakage of methane from production, transportation to market actually erases any climate benefit you get from natural gas power generation versus coal power generation. So one of the things that has really been pushing for natural gas implementation is this reduction in CO2 emissions from power generation. However, a little bit of methane leaking erases any gains you get from the point of power production. And so we really need to understand how much methane is leaking through these transportation networks. And that's one of the things this study was designed to look at. Elevated CH4 emissions or elevated methane emissions not only indicate leakage, but they also indicate that other pollutants associated with the methane will be emitted as well. So while we focused our measurements on methane because we have instrumentation to measure that very, very precisely, other pollutants will also be emitted during those leaks. Now, it depends on where the leak is coming from as to which pollutants will be co-emitted with the methane. And so whether it's from a pipeline or it's from a compressor station, the other pollutants that are emitted will differ. Methane by itself is not a direct health concern. That is to say that you can breathe elevated levels of methane and it's not going to harm your health directly. However, it will impact climate and through that have exacerbations of bad air quality and changes in weather patterns, as Matt mentioned. So methane by itself is primarily a climate problem, and some of the associated pollutants with methane may also be health problems, but methane itself is not necessarily a health concern. So I'm going to discuss our measurements from two studies that we performed in 2012 and 2015, with our 2012 measurements featuring a more complete suite of gas phase and particle measurements, including benzene, toluene, particle composition, particle number. And we made measurements in 2012 in both the northeast and the southwestern parts of Pennsylvania. Our 2015 measurements were focused primarily in the northeastern section of the state and focused more on methane. We also measured carbon monoxide, carbon dioxide, and a few other associated pollutants, but we were focused primarily on methane in the 2015 measurements. In the upper left section of the slide, you can see the number of producing unconventional wells in Pennsylvania with our sampling tracks where we drove in 2012 and 2015. In 2012, the purple routes are where we drove, and in 2015, the black route is where we drove. We focused in both studies at emissions testing downwind of facilities in the Marcellus Shale, and this is because we did not have site access in either study. And so we were looking at emissions measured outside of the facility, downwind, and we used different methods to quantify the leakage rates from these facilities, including compressor stations, producing well pads, drill rigs, well completions. So I'm going to start by giving kind of three key study results that I'm going to talk about in more depth in subsequent slides, but I wanted to focus and just give you guys an idea of what we saw and then go into more detail. So if we combine the measurements from our 2012 and 2015 findings, we see that the background concentrations of methane in the northeast region of the state, where we made measurements in both years, have increased substantially. Secondly, the emissions from transportation-related infrastructure are variable, but significant, and we see significant emissions from various different infrastructure, or compressor stations especially. And thirdly, one of the focuses was to look at methane emissions from pipeline infrastructure as well. And so in areas where we were within 100 meters of buried pipelines, we see increased methane levels above background in roughly 1 in 5 of our measurements, and significant increases in 8% of those measurements. And these enhancements are likely due to the pipeline underground, and so leakage from that pipeline going through the ground and then into the atmosphere where we're making our measurements. So starting with result 1, the green line in this figure is what we're calling this local scale background. And behind that in gray, you can see the 1-second sampling that we do with our instrument. And so the focus of this part of the study was to look at what are the background levels as we drive around in the northeastern part of the state and in 2012 in the southwestern part of the state. What are the background levels in different regions? And this gives us kind of a baseline that we can look at how things have changed over this three-year period. So what we find, and again, the background, why we care about this and what's important, is that production has roughly doubled, whereas the number of new wells being put in every year has decreased by roughly a factor of 2. So taking that into account when we're looking at this, what we find is that overall the background methane in the southwestern part of the state is the highest. So let me take a step back. The figure that you see here, the blue dashed line, is the background levels of methane for the mid-latitudes if there were no sources of methane. This is just the fact that there is some methane in the atmosphere that comes from a variety of different processes. Enhancements above that dashed blue line are due to activities such as well drilling. There could be impacts from agriculture, and natural gas infrastructure is obviously one of the things we're really interested in investigating. So based on our background analysis, what we found is in the southwestern part of Pennsylvania, we saw significantly elevated levels of background methane in 2012 that we still have not reached in the northeastern part of the state. What we can also look at is the increase from 2012 to 2015 of the background methane in the northeastern part of the state. And this is important specifically for the reasons Matt mentioned in the introduction. Methane is a massive climate force. It will lead to changes in weather. It identifies that the leakage in the natural gas infrastructure and transmission and storage. And so what we see is that in 2012, our methane emissions were about 50 parts per billion by volume elevated above background. It's a whole lot, but it's definitely significant, and it's very clear that it's an increase above the background. In 2015, that elevation has gone up by a factor of 3 to about 150 parts per billion by volume. This is clearly due to increased infrastructure. Farming rates haven't changed in the area, so the contribution of increased methane from agriculture will be roughly the same. So this increase of a factor of 3 is due to increased production and transmission of natural gas. New wells are down, so it's not due to that. It really does seem to be due to this increased production, storage, and transport. So that's an important result because this has massive impacts on climate as well as the environment. The second result that I mentioned before is that the emissions from transportation, from transmission and storage. And so in the 2015 measurements, we used the EPA test method 33A for the leak rate calculation. What this allows us to do is assess what the emissions were. Does that sound for me, Matt?
No, it's not. I think we have Rick. If you're not on mute, can you hit the mute button, please? And I'll.
As soon as I find it, thank you.
Gotcha.
I didn't know if that was a timer or something. I should hurry up.
A few more minutes on the maybe 3 to 5 minutes on the presentation, then we'll have Q&A.
Okay, great. Okay, so the other test method, 33A, is an EPA method for pollutant measurement, and it allows us to calculate leak rates from different facilities. And what we need is very fast sampling measurements on the order of 1 second of both meteorology, so wind speed, wind direction, as well as concentrations such of methane and other pollutants. So we sampled at compressor stations, metering stations, and well pads to assess these leak rates. So here's a table of some of the data that we generated from this study. I don't expect anyone to read this in detail, but what I do want you to focus on is that the most significant emissions that we measured came from compressor stations. So these rates are given in grams per second from the calculation, but assuming that leak rate is roughly constant throughout the day, 16 gram per second leak rate, which is what we saw at the Leedy compressor and storage facility, equates to about 1.5 tons of methane per day. And so that's a standard ton, 2,000 pounds of methane per day. So actually more like 3,000 pounds of methane per day are leaking from that facility. These emission rates, however, were highly variable and between even the same infrastructure, and so we definitely need more studies to characterize more facilities. There's more than these are spread all across the state and in various sizes, and so to really understand the emission rates of the Marcellus Shale as a whole, we really need to need to have a lot more sampling of these facilities. Finally, some of the sites we did sample we weren't able to measure leak rates due to unfavorable winds or the non-existence of nearby roads, because we need to be downwind of the facility but close enough that we can still measure within that plume. And so not all wind directions were favorable for downwind sampling. Continuing on that particular result, some additional observations we made. We were not able to calculate emission rates at the Teal compressor station. However, this site had the largest enhancements of methane that we saw during the study, and they were huge. 50 parts per million is an enormous enhancement of methane, and that we observed downwind of the site. At this site, they were also performing construction and modifications of the facility, so there could be leakages due to that process. It's not clear what exactly they were doing. It's also important to note that the Tuasa-Thompson leak rate measured of about 1.6 grams per second was lower than the emission rate we calculated in our 2012 study, and so there are a couple reasons this could be happening. We used a different methodology this time to calculate leak rates, which may not be as accurate. In addition, they could have upgraded or changed some of the facility operating and reduced that leak rate through better maintenance. Finally, the last result, and then we'll be finished, is the pipeline enhancements. And so this was one of the motivations for the study. This is a picture from a National Geographic article looking at the wildlife fragmentation or habitat fragmentation from pipelines being put into these areas. And one of the reasons it's hard to make samplings of pipelines is we're making on-road measurements and there aren't a lot of roads crisscrossing the pipelines. So what we've done is we've taken data sampled with our 1-second measurement of methane only from within 100 meters of where pipelines were crossing roads. And we looked at whether we saw an enhancement of methane above background and how frequently we saw that enhancement. So whenever we made a pipeline crossing on the road, we looked very carefully at that data to see what enhancements we saw. And so what this figure is on the left is called a cumulative probability diagram. And so the y-axis shows you at what level we noticed enhancements above background. And we see that at roughly 0.72. So 72% of the measurements were beneath this threshold of enhancement in the background with statistical certainty. So 18% of the measurements we made, therefore, were elevated. I'm sorry, at 82% is where we crossed. 18% of the measurements we made within 100 meters of pipelines were elevated. 8% of those were above 50 parts per billion, and 4% of those were above 100 parts per billion, which are significant enhancements that are very clear, well above the background level. And so with this limited data set, we are able to clearly identify enhancements from pipeline infrastructure above background concentrations of methane. So some closing thoughts that will lead into this second part of the webinar is that newer technologies implemented at transmission infrastructure will likely reduce leakage as compared to older technologies, and this is because they're designed to do that. However, leakage from improper maintenance or human error at these infrastructures will not necessarily decrease and will not therefore decrease methane emissions. So as production increases and as our infrastructure ages, one of the questions that we have in my group, and we plan to make more measurements in the future, is what will happen to these emissions, what will happen to background levels of methane in these regions. So these are the three results that I went into detail discussing, and I'm happy to answer any questions you guys might have.
Pete, did you want to do, you can take another minute if you want to do the summary slide here, and then we'll take questions.
Okay, so I can just summarize the results again. First key result is that the background methane in the northeast region of Pennsylvania has increased substantially from our 2012 to 2015 measurements. This is likely due to the increased production and transportation of methane to market and not due to increased drilling, because drilling has actually decreased. Emissions from transmission-related infrastructure are variable, but significant and measurable at nearly all of the facilities we were able to do this measurement. And finally, methane concentrations near these buried pipelines showed elevated levels of methane in at least roughly 20% of the measurements, which is indicative of leakage from these pipelines and potential problems from that.
Thanks so much, Dr. DiCarlo, for your presentation. I'd like to open it up for questions from the audience. If you have a question, please type it in the chat box, which you can find on your toolbar. It should be towards the bottom. You might have to click the plus button to enlarge it and type your question in. And then I'll just give a few seconds to see if we get any questions from the audience. Let's see if anyone...
You can also answer questions at the end if that makes sense, if people want to think about things.
Yeah, let's see. Okay, actually I see a few questions here coming in.
Okay.
Okay. All right. Great. Okay, let's see here. Some of them are technology questions. Yes, a recording of the PowerPoint. A recording of this webinar will be provided afterwards on Clean Air Council's website. Someone's asking about what emissions along with methane could cause health issues.
That's a great question. I think one of the questions that a lot of people have is what are potential health risks if methane is not something that's likely to cause health problems. That again depends on where the leaks are or what process is going on. So if it's a pipeline that's leaking, whatever else is in the pipeline would also be emitted along with the methane. And so this typically involves some ethane, which is one carbon more than methane. It's C2H6. That's also not a huge health risk, but they also use things like methanol as a pipeline antifreeze to reduce ice buildup in the pipelines, and so that will also come off, which can have some health effects, but it again will be low concentration. I think more likely is at compressor stations where there are some flashing emissions or venting or other issues. You can have potentially other gases that can lead to health effects, but it really depends on the compressor station technology that's being used. Many compressor stations use natural gas engines. Some use electric compressors, which lower emissions, which would actually be ideal. In our 2012 study, we did actually identify ultrafine emissions, so particle emissions, very, very small particles that can go in more deeply into your lungs. We noted an enhancement of those particles downwind of compressor stations, but the particles were too small to get a good handle on what they were made of. So it's not quite clear what's in that. So I hope that answers the questions. I think it really just depends on where the process is that the leak is occurring and what's in the pipeline or the facility at that point.
There was a similar follow-up question from Julia Mawson about is there anything that happens, any chemical reactions that can happen for methane in the atmosphere that could convert it into other more hazardous compounds?
So methane is actually a pretty stable compound. It has a lifetime in the atmosphere of roughly 9 years. So emissions from the Marcellus Shale area are going to go around the globe and mix globally before they really go away quickly. Methane typically oxidizes to CO2. So after 9 years, most of the methane will have converted from methane to carbon dioxide, which again isn't a big health problem, but it's definitely a climate issue, and one of the reasons we care about the methane emissions from a climate perspective.
Thanks. Question from Becky Meyer about, can you talk a little bit more about specifically how you measured with your equipment, how you did the actual monitoring, what that looked like? They're asking from the air, ground, and you did describe it's on the ground, but can you just give a brief description of what that looked like?
Yeah, so in both 2012 and 2015, I can try to show. So in 2012, we used a facility, the Aerodyne Mobile Laboratory, which we partnered with a company out of Boston, Aerodyne, to make these measurements. And so we were driving around in what looks like a milk truck. In 2015, it was a similar setup where we were driving around in a Ford cargo van that we have at Drexel. Both of these measurements were utilizing mobile measurements at 1 second resolution, so we were making measurements every 1 second, and we had GPS coordinates for all of those measurements too. So spatially we have information on where we are, and we have measurement on the concentrations of the different species that we measured. So they were all ground-based, measured at, on road at about a few meters off the ground, and looking at the concentrations spatially.
Great, thanks. Question on a specific compressor station that was in the study. Was the Leidy compressor station run on electricity or natural gas?
That is, I'm not, off the top of my head, I'm not 100% sure, but I believe it was natural gas powered compressor.
Yeah. Yeah, because that one, you said that there was a pretty high quantity of emissions.
There was also a storage field right around there as well.
Okay. See, yeah, you already covered this question about electric. The question about sort of what we're going to do with this, has it been shared with DEP? I can answer that. No, it has not been. Can you talk about, someone asked if this study is going to be published. Can you talk a little bit about the future of that work?
Yes, we do actually have a manuscript in preparation for publication, focusing a lot on the background methane concentrations, along with some other species that we also measured in 2012. I can send, once that's published, I can send a link to the Clean Air Council to put on their website, and it can be shared that way. We do have a publication out on our 2012 measurements that is freely available in the journal Environmental Science and Technology, and I can also make that link available for people who are interested. We paid extra so that anyone can download it and read it. It is open source.
And along similar lines, when asked if we've submitted the findings to FERC, so when they're made public, really anyone could submit these to FERC in their comments.
Yes.
Question, we'll do maybe like one or two more quick questions. We actually have a lot of them, so thanks everyone for your participation. Question about, and we could also bring in Rick for this as well, about the buried pipelines that were leaking in your study. Do we know why? Like, where the question is, are they from the seals between the pipelines? Why is it that they're leaking? How about, and they're asking about this from Faith Zerby, asking about above ground valve stations. Is that a place where there's more methane leakage happening?
So I'll try to address what I can. As to the reason why the buried pipelines are leaking, it's unclear. Our measurements only allow us to see whether concentrations of methane are enhanced, but they don't pinpoint where it could be coming from. It would require actually looking at the pipeline itself, and I think there are some ways to do that, but we can't dig up a pipeline and look. And again, we don't know where in that 100 meter, plus or minus 100 meters near the pipeline, where exactly the leak is coming from. The second question, what was the second part of the question, Matt?
It's about metering stations. I believe
metering stations.
You should look at
Yes.
metering stations to see if that was significant or not.
Yeah, so our 2012 measurements, we did identify some pretty significant leaks from a metering station. The metering stations we sampled in the 2015 study didn't show the high rates of methane leakage that we saw at the compressor stations, but they were measurable downwind, and we did see leakage at those metering stations as well.
Specific question on your sampling. How long did you take the samples for? The question from Julia Mawson, every second for how long, what seasons, etc.
Okay, so our sampling was done in September in both 2012 and 2015. We typically drive for 8 to 10 hours a day, and during that time make measurements continuously. So 1 second measurements for 8 hours during the day, and then we'd often let the instrument run at night when the car was parked. So 60 seconds in 60 minutes in 8 hours is thousands of measurements every time we went out and drove, and we drove for typically 1 to 2 weeks, depending on the 2012 or 2015 study, to make these measurements.
So we had a lot of great questions, but we can't get through all of them. That's a lot of them, and I tried to group several together. So thanks so much, the audience, for participating, and thank you, Dr. DiCarlo. And at this time, I'm going to turn it over to Richard Kuprowitz with AccuFacts, and I'm just going to change the presenter real quick right here. So I want to introduce Richard Kuprowitz. He is the president of AccuFacts Incorporated. He has over 40 years of experience in the energy industry, including gas and liquid pipeline operation, design, siting, engineering, regulatory compliance, emergency response, safety, and risk management. His special focus is on proper design and operation in areas of unique population density or of an environmentally sensitive nature. He is a certified safety management engineer, and he has developed and performed safety and risk management and assessment analysis for various clients representing chemical plants, LNG facilities, refineries, and pipelines. He served 8 years on the Washington State Citizens Committee on Pipeline Safety. Thanks for joining us today. This is Richard Kuprowitz, everyone. Thank you.
Thank you. I don't have a slide presentation today. Unfortunately, my schedule didn't allow me to put that all together, but a lot of my comments today will be based off of a report I issued to the Clean Air Council in December of 2015. I think there's a couple key basic issues that many people need to understand in what I call today's over-information, misinformation age, when everything's coming at you 24/7, and it's almost impossible to keep ahead of everything. But there are some key basic principles that might help people to understand how best to attack or maybe deal with this. And I appreciate the earlier presentation. None of that is necessarily new information to me, but it's important to get that information out to parties so that they can start developing policies and procedures to actually deal with issues, because the methane emissions can have a very serious impact on the world. I think a key issue that everybody needs to understand is, by the nature of the safety regulations governing pipeline safety in the United States, it's not illegal to leak methane. Okay? It's not even illegal to leak methane that can develop hazardous leaks. All right? And so the development of pipeline safety regulations of such that they recognize that most methane releases historically are lighter than air, and they tend to rise. And so from a safety perspective, they normally won't generate a safety issue. Now, I need to be very fair here. That doesn't mean that all leaks are not unsafe. There are some that can be very dangerous, and the public and the regulatory agencies are starting to understand that methane can be a very serious form of global warming, offsetting even CO2 if we aren't careful. So everybody needs to understand, not only within the industry, but the regulatory bodies and the way we want to approach this issue, is we're starting from a position that it's okay to leak methane. Now, I don't necessarily agree with that, but there's a lot of things that need to be done if you want to attack reducing methane emissions. I think also it's very important within the industry, if you wish, that produces methane from underground formations and whatever, and then transports it and then gets it to the consumer, that there are three basic groupings, if you wish, within the industry of the organizations that deal with methane. First, there's the production facilities, like the well drillers, like the Marcellus Shale and all that, and they're mainly going to be lots of wells approaching it in various different ways, whose primary focus is to get the methane out of the ground. And methane doesn't come out in its pure form, but it's 90% methane or usually greater in many fields. So the production guys are focused on getting it out of the ground. They are not covered by current pipeline safety regulations meant to protect the public from transporting hazardous materials like methane in pipelines. I think the public needs to understand that. And so when you move from production to transportation, and transportation can be gathering, massive storage like in salt caverns and whatever, and obviously the major transmission pipelines, that's a different animal. That latter group is covered under pipeline safety regulations, and so it might make sense to morph off of existing pipeline safety regulations and merge the issues of how we reduce methane emissions. The third group in the industry is what we call the distribution. They take the gas, usually through metering and pressure letdown stations, off of transmission systems, and they distribute it, usually within towns and cities, to the ultimate consumers, mainly the homes and industry, especially power plants. And so those are covered, the distribution and the transmission systems are covered by pipeline safety regulations. And there has been an evolution in the last 10 or 15 years to improve on pipeline safety to reduce some of these terrible tragedies that you've seen occur in transmission and in distribution pipelines. But it's important to recognize production guys are specifically exempt from pipeline safety regulation. There is an effort under the federal regulations to start capturing what we call gathering lines, which are in between production and transmission lines, but they act more like transmission lines if they should fail under pipeline safety regulations. So when you start thinking about how to deal with methane emissions and how best to deal with them and start reducing them, understand the three major phases of the industry, and they change in terms of their complexity and the potential to leak methane. All of them do leak methane. Some, I think you'll find, will be, by their nature, more likely to emit than the less complex forms of the industry, like some of the transmission. Now, I'm not getting the transmission off the hook here, okay, because I think, as you'll see, even in transmission, by the nature of their design, there can be super emitters in the transmission system, and you sure as heck can find super emitters if you were to survey them with the right newer technologies that can remotely monitor methane emissions in both production and distribution. That's comes as no surprise. There has been advancements in remote monitoring of methane emissions, probably started in about 20 years ago with technology using lasers where they could remotely identify emissions. And that was mainly started in Europe, and then it got morphed over into the US. And it's become a more advancing technology in the last 10 or 15 years here in the US, and it's become so sophisticated that I'm told now that the remote measurement emission detectors, either by vehicle or helicopter or by airplane, the technology has become so sophisticated that it actually can distinguish between organic methane emitters like cows or super emitters like some of the compressor stations or production wells and distribution systems that have massive leakage for whatever reason. So as the technology is advanced, the issue is going to be, where do you want to deal with, how to deal with the methane emissions? If you're trying to capture all methane emissions right now, if you just started passing regulations or efforts to try to deal with that, you're going to be spending a lot of resources not getting super emitters. My report talks about focusing in on the super emitters, especially with the remote technologies, where you can independently check to see if, let's say, a transmission pipeline has a compressor station that's become a super emitter. It could be a super emitter by its design. Many pipeline companies have designed their compressor stations not to be a methane super emitter, though they can super emit from time to time by the nature of how they blow down. And blow down is whether they're doing certain maintenance activities within the compressor station or on the main line where they have to de-inventory the pipeline. Transmission pipelines, by their nature, hold many thousands of tons of methane within their main pipelines. And so if they can't isolate the pipeline enough, they may have to blow down segments of their pipeline, which can be a source of extreme methane emissions. But the problem with that is pipelines don't blow down their inventories very frequently. So it can be frustrating if you're out there trying to remotely measure massive super emitters of methane on transmission pipelines. You may not find one, but that doesn't mean that one can't occur, because when you're not around, somebody's blowing down their line. So it's important to have remote monitoring of the gas infrastructure, and to make that remote monitoring somewhat unannounced. And it'll become obvious as you do that within the industry, across production, transmission, and distribution. You'll identify super emitters where the biggest bang for your buck should be spent to really get a handle on massively reducing methane emissions. Now, the last point I want to make, and it's made in our report, is voluntary programs, in my opinion, will not work to substantially reduce the methane super emitters. If the industry, because of its history, and methane emissions historically have not been illegal to emit, if they haven't developed systems to reduce super emitters, when oil prices were at somewhere around $100 a barrel, how in the heck are they going to come up with the financing to justify capital or maintenance expenses to markedly reduce methane emissions when oil's somewhere between 3 and 50? So something doesn't quite jive here. I'm a firm believer of mandating carefully thought out regulatory requirements that place the burden on the pipeline operator to incorporate that process within his operation. So that's pretty well it, a summary in a nutshell of that report. I think, Matt, the report is public. Anybody can get access to it, and there should be no real secrets in it. That's about all I have. If there's any questions, I can take some questions.
Yeah, we will be releasing the report with alongside the report from Dr. DiCarlo, sort of as a package within the next several weeks, so folks can see all that together. Rick, could I just ask you, as a preliminary kind of follow-up to the presentation, to talk a little bit about how you, what you did in your analysis going through the pipeline technologies that are currently being used, and your opinion about the technologies that are suggested in EPA natural gas stars recommendations?
Yeah, so I went through the various, EPA has spent a lot of time on this, to their credit, to try to get, obviously if they can get something to work through volunteer, fine. My premise is, gee, that's nice, but the economics are not going to work, right? And so you have to go that next step, especially given the extensive history where, in fairness to the industry, they weren't required to really cap methane releases. It's hard enough to get to those that are really dangerous, much less in a timely manner, much less the general, historically, what we call, they wouldn't be a safety issue, so they could leak. So did an extensive review of the EPA's programs, tried to give them the benefit of the doubt. I've got extensive background across many companies. Some I can talk about, some I cannot, where I clearly know where many of the super emitters may be, per se, in some of the areas in this country related to production. Also understand that there are transmission pipelines the bulk of their design should not be super emitters, with the exception of the blowdowns. But I don't want to paint a broad brush here. There are some transmission pipelines, by the nature of the operation, where they haven't really focused on reducing their super emission of methane and the other things that go with it.
And you talked about, I'll do one more follow-up question, and then I'll take a few from the audience here. You talked about in your report taking a top-down methane independent field measurement and audit approach. You're saying that's what is really needed. Can you provide a little bit more detail about what that means?
No, thank you. That's an important point in the report. It's important that because of some of the random nature and if people know they're going to be checked, they'll take quick-term measures to temporarily reduce the methane emissions, okay, whether it be production, transmission, or distribution. It's a little harder with distribution given their complexities. But they can taint the evidence, if you wish. And so, especially given the development of the technologies that allow more, the aerial flyby and the drive-by stuff, there are ways for them to kind of survey and look for super emitters unannounced, okay? And for super emitters that are repeat offenders, you can put fixed monitoring where they can be remotely monitored. But I think it's important that what I call top-down, the regulators need to develop regulations that allow them to remotely and independently, unannounced, check for major methane emissions. Do we go all the way to zero emissions? I think that's many decades away, given the complexities of the systems and the challenges. But the top-down, the regulations should be written where the enforcement would clearly say we have the right to randomly, and we don't have to be on your facility to even do this, given the technologies, but to randomly check you, and if we find you super emitting too frequently here, we are going to ask you to modify the design or change your maintenance practices or a combination of both, or you're going to start getting heavy fines. Let me give one minor point here. This was on a transportation system related to transmission. The Alaso Canyon, also known as the Porter Ranch emission here, that started in October of 2015 and went through about February of 2016. That is in a storage facility considered to be transmission, okay, in which they're using underground salt caverns to store methane. And from what apparently has gone here, a well that was used to service and gain access connecting the transmission pipelines to the cavern did not have appropriate levels of safety. And so they had a corrosion leak in the main well tubing where they were not able to shut that off. And so that emitted many thousands of metric tons of net methane because somebody chose to eliminate a level of safety called a subsurface safety valve, whose purpose is to shut those wells off so that you don't allow an infinite reservoir of gas to leak to the atmosphere. So that's an example, and in the last 7 or 8 months, the public has seen where the remote top-down monitoring by this newer developing technology has really caught people not telling the truth about their methane emissions.
Thanks, Rick. We have a question here from Julia Mawson about how can we monitor or regulate blowdowns? Can we make it required that industry report when they're going to occur? How to deal with unexpected blowdowns is another question I'll tack onto that.
Yeah, those are fair questions. First of all, a properly designed, operated, maintained transmission pipeline will not have frequent blowdowns. All right. The industry, there's some new notice of proposed rulemaking for pipeline safety covering gas gathering and gas transmission pipelines, where some in the industry are trying to advocate, because of the need for safety, that they may have to do additional testing on some of these major pipelines, they may have to blow down more frequently. Well, too bad. Go ahead and blow down more frequently, because if you rupture the pipeline, it's going to emit a lot of gas, all right? So there are ways for you to control the number of blowdowns in a pipeline system and to minimize those. There are also ways, if you schedule blowdowns, there are technologies where they can keep the amount of tonnage released by a blowdown substantially reduced. And I won't go into details, but there are ways to deal with that. My point is, some in the industry are trying to use this methane emission scare as a possible excuse not to ensure transmission pipelines are safe. And that shame on industry, okay, if some of those people are going to use that tactic.
Okay, thanks. Thanks, Rick. Let's see. Okay, got that one. A question from Susan Van Dulsen. If you can clarify, you mentioned before that you thought pipeline safety regulations from distribution systems, how they are covered under some safety regulations. Clarify how those could help in regulating methane emissions from the transmission sector.
Somewhere around 2005 and 6, PHMSA, the Pipeline Hazardous Materials Safety Administration, the federal agency charged with transportation pipeline safety, such as distribution, enacted with a lot of effort from the public, industry, and the regulators across at state levels as well, because most distribution pipelines, if not all of them, are fall under federal as well, but also state regulations. So some states can have regulations not in conflict with federal regulation, but in addition to federal regulation. But that regulation has taken a quantum leap. Again, it's one of those where it's an evolution regulation. It's been in effect now for 5 or 6 years, and it's focused, it doesn't say you can't have hazardous leaks in distribution systems, but if you do, you've got to report, when you repair them and, what was their cause. And what's happened there is many responsible pipeline distribution operators are asking to deal with their upgrade of their distribution systems so that they're replacing pipeline or upgrading their system so that, one, they don't have as many hazardous leaks, and two, they're getting rid of the more what we call grade 2 and 3 leaks. And in some states, and I won't get into specific states because I'm still investigating for various parties on some states, we have seen in some states the regulators have embraced that, and that's an example where pipeline safety in concert with good regulation at the federal level is working to reduce many of the nuisance methane releases, both hazardous and nuisance, in distribution systems. Unfortunately, we still have a long way to go in some parts of the country, like in the Northeast, on distribution systems, as some of the new technologies have clearly indicated in cities like Washington and Boston, for example.
Okay, thanks. I know we're almost to time, or basically to time now, but if folks can stay on for a few more minutes, maybe you can take just a couple more questions here.
I'll get off my webcam here.
Let's see. Someone's asking, I'm not sure if you can, this is sort of a health-related question, so I'm not sure if this is something you can answer, Rick, but someone's asking, they live a few hundred feet from a compressor station. This is Mike Martin. Are there direct health risks during, like when a super emitter is, or an incident is happening, like a blowdown from a large compressor station?
I'm not the health expert guy, but from a general emission point of view, I'm well aware of some very serious health monitoring studies underway in a couple states where at compressor stations, because methane tends to be lighter than air, it tends to rise. I think the doctor earlier had commented, there are, however, at compressor stations, other emissions that are non-methane that can be a problem from a health perspective, and some of those are related to particulate emissions. Formaldehyde is another one that may show up depending on what type of compressor station they have. So there are other forms of emission besides methane, but in general, you don't have to get very far from a compressor station where the methane emissions from the compressor station itself within the fence boundary would not be a problem. Okay, and again, I don't want to act like I'm a doctor or expert in that area, but I've seen a lot of health studies being carried on.
All right, thanks. Let's see, we have one here. Can you address the impact of topography on the safety of a pipeline? This is from David Lauer. He says I'm going to get the pipeline name here wrong, pronunciation, but there's one pipeline, Antino Palampo pipeline, goes up and down throughout a mountainous terrain versus another pipeline which is mostly flat.
In terms of natural gas, it probably isn't going to make a lot of difference because in general, the industry has always touted how we could have methane leaks because methane's lighter than air and it rises in the air fairly quickly. And where it becomes more dangerous is where it can become trapped, capped, like in a building or in a compressor shed or whatever. And that basically is usually true. There are some other issues, but generally topography for a natural gas pipeline is not going to be as big an issue in terms if they should release methane. Now the super emitters, there may be some other things carried on along with the methane, but generally topography is not the biggest, except in a pipeline rupture where the rupture is where the pipeline has failed in microseconds. Massive pipe failure, big crater, big fireballs usually. The topography could shield you from the heat flux, but generally topography is not a major factor of influence in how a pipeline is operated for a gas transmission pipeline.
Great, thanks.
Can I just jump in quickly and clarify something?
Please do.
This is Pete. Methane, when released to the atmosphere, doesn't actually rise. It just dilutes in the atmosphere. The timescale for mixing is actually much shorter than and the turbulence in the atmosphere makes it mix, but it doesn't rise. If it did, we'd see actually a gradient of methane with height that we don't see. So it's really just it dilutes in the atmosphere.
Thanks for that clarification point. We have a question, and Dr. DiCarlo brought this up earlier about older pipelines versus newer pipelines. Could one or both of you talk about why we would see more frequent leakage from an older pipeline versus a new one? Maybe start with Rick.
Well, it's a function of not necessarily age, but complexity. And so if older pipelines may have more valves, like meter stations and things like that, more pipe connections and whatever, the newer pipelines tend to have welded, they're all welded, not coupling. So they tend to be less complex. I'm a little perplexed by the reading of methane around buried pipeline. Even older pipelines shouldn't have that many connections, but again, it depends on the specific pipeline. Now, I want to couch old versus new. New doesn't necessarily mean better. If a bunch of monkeys are putting the pipeline together, new. If it's a newer pipeline with newer steels, newer technologies, tends to be less complex, less potential sources for release. But they still have to have certain valves. The valve packing technologies have come a long ways, but they don't completely eliminate all leakage. And so it's not so much age versus old or new, but it's how complex and how well maintained has it been.
All right, thank you. And with that, we're going to have to end it here. So we have a lot of great questions coming in. Actually, here's one follow-up I got to give for Faith Zerby here, follow-up on what you were just talking about what about right angles and alternate routes around certain features when pipelines are built with different joints and welding spots. Do the angles and possibly more welding cause more leaks?
No, modern welding technology and I don't want to sound evasive, I want to be very specific. If a pipeline company has modern welding techniques with proper quality control and quality assurances, the welds, especially the large girth welds, will be stronger than the parent material of the pipe. And so again, what we're finding is some new pipelines, the welds aren't as good as they should be. We're seeing some of the older weld technologies of 20 or 30 years ago, where they may not have had the better inspection methods that they have nowadays. We're seeing some catastrophic girth weld failures, such as the more recent one in Pennsylvania, that can occur. You know, poor welds can leak. They're more likely not to leak.
Is there anything to do about the age of a weld on some of these older pipelines that would indicate when when there might be a failure?
Well, you'll probably hear a lot about the word vintage in the notice of proposed rulemaking that PHMSA has issued a couple months ago that they're asking to incorporate into regulation. Vintage has more to do with the type of welding techniques. Welding techniques of 50 or 80 years ago are nowhere near as good as the newer welding techniques. However, again, new welding techniques, if monkeys are doing this and they're in a rush to get a pipeline built and they cut corners, and there are pipeline companies that'll do that, though there are also a lot of pipeline companies who will not do that. The welds can be stronger than the parent metal.
Okay, thank you, Richard. So that concludes our webinar presentation. I want to thank our presenters today, Dr. Peter DiCarlo with Drexel University and Richard Cooperwitz with Acufex. Thanks so much for your time today, and thank you all the participants who called in and asked wonderful questions. And this now concludes our webinar.